Pretty good? Does it make it, to me at least, that the later ones actually make more sense than the beginning ones? I don't know about you, but it seems to help me when there's more of a function. Like, for example, on part A, what do you think even if you understood the whole structure, what do you think the most common mistake is in part A when I ask it to a bunch of kids? What do you think the most common mistake out of the 4 terms you need right here? Which one do you think people get wrong? The 0, yeah. They don't do they do the dvdx wrong. They say dvdx is like 3. It's not exact. It is 0 because it doesn't actually. It's constant, right? How do the rest of them go? I see some 5s and 2x. Pretty good. Pretty good on that one. Okay, you ready to jump a little bit and talk about a little more theory about multi-dimensional functions? Let's talk about this one right here. Let's talk about this one right here. So easy to go and spin in circles. It's so easy to spin in circles. So let's do this here. This is what I'd like to do. We're going to break this down sentence by sentence. We're literally just going to break it down sentence by sentence. The air pressure is decreasing at a rate of 2 pascals per kilometer in the easterly direction. So, okay, so we have some sort of island right here, and as you go this way, what's happening? -2, is it P? Pascal? P? 2 pascals per kilometer, right? So you might, okay, that's what's from the island. Nice. Okay, that's great. So you know that as you move to the right, as you move east of the island, what happens? The air pressure goes down. The air pressure goes down. Okay, so you're on your ship here. Nice. Okay, you're on your ship. In addition, the air pressure is dropping at a constant rate with respect to time everywhere. So the air pressure is just going down with respect to time everywhere. Does that make sense, everybody? So regardless of where you are in relation to the island, the air pressure will decrease with respect to what? Time. So let's call this air pressure is dropping at a constant rate with respect to time everywhere. Let's just call that, what do we want to call that in terms of notation? If air pressure is dropping with respect to time, what do you want to call it? What's the easiest way? What's the easy thing we could call it? You did it. A bunch of you did it. Yeah. dp what? Partial p, partial t. We okay with that? So regardless of where you are, what does that mean? What's the denominator there? The t? So t is changing. What isn't changing? The distance from the island. If irregardless of distance from the island, the air pressure is changing at a certain amount. Are we okay so far? Yeah. Right. But if you are a certain distance, if you are moving away from the island, there's something else that's going into it, correct? That's the distance you are from the island. Okay, a ship is sailing eastward. A ship is sailing eastward at 10 kilometers an hour past the island. Okay, so how are we going to write that? How are we going to bring that into the equation?
You kind of don't need to do any of this. I just realized.
Hold on one sec. Wait. There might be shortcuts. Okay. You can absolutely do a lot of these by logic. You have to do it by calculus for 2 reasons. 3 reasons I can think of actually. 1, to get credit. 2, if I asked you to do anything more challenging than this, if I started adding in more variables, like how many seagulls are clustered around the thing, I don't know, right? You're going to get lost. You're not going to be able to do it just like that. Those are really the 2 reasons right there. Yeah. Okay, so the point is this. Yeah. The point is this. We have to label this something else. ds, it's the barometric pressure on the ship. It's the barometric pressure on the ship is changing at a rate of 50 pascals in 2 hours. So do we actually have a numeric answer for ds dt? What is that? -25.
Is that including?
Exactly, it's including everything. Exactly. That negative. They have some sort of fun up there. This includes everything. This includes the boat's motion and dp dt. So here's the thing. We need to now write an equation for partial s, partial t. What is that going to be? What is that going to be? What goes into s? X and t, right? X and t. So it's going to be partial what times partial what is the first thing we want to do. You can pick it. Which one do you want to go first? Partial what? I think it's partial p partial x times what? Partial t plus what? T. And then technically what goes right here? Partial t, but what is that? That's just 1, right? Now, which ones do we have numbers for? Do we actually have numeric numbers for? We know the first one, right? 25. Do we know dp dx?
Yeah.
What is it? We wrote it right there somewhere, right?
No.
Oh, dx dt. Oh, it's the first sentence, right? Is decreasing at 2. Oh, we do have something up there. What is that? D what? dx, right? The drop in pressure because of the movement, because of the motion, not because of the atmospheric. So what's that going to be? Negative what? So what do you end up with here? Negative 2 times what? 10 plus this. The challenge here, and the thing I really wanted to focus in on here, is we get really locked into setting up things to solve for the thing on the left. Is that what we're solving for now? No. So we now know negative 25 plus 20 is equal to partial p, which is what? Negative 5. And what's the units on that? How do you feel about that one? It's a challenge. It is a challenge. I'm not